Hello, my name is Christopher, and today we're going to be doing a problem for the epsilon delta definition of the limit. And the problem is the limit as x approaches -3 of the polynomial x squared plus 3x. And what we're looking for is we're looking to find the limit and then to use the precise definition of a limit to show that that's actually the limit. So first we want to evaluate the limit, and we could do that by plugging in our -3. And that's going to end up being 0, which is what we found graphically. So we want to use this definition now to prove that this actually is the limit. And the way we're going to work backwards. And the way I really like to think about it is that f of x minus L is going to be less than 0 whenever x minus A is less than delta. Right. So
This is epsilon or
oh, epsilon, not 0.
So I was like, what's going on?
Okay. It's a new definition. So we're going to start with this piece here, and so it's the absolute value of f of x. F of x in this case is going to be x squared plus 3x minus L, or limit. In this case it's going to be 0. And that's going to be less than our epsilon. Now this simplifies to x squared plus 3x. It's less than epsilon. And our goal here is to manipulate this algebraically so that we could find this piece here, x minus a, the absolute value of x minus a. In this case, our a is -3. So we're looking for the absolute value of x minus -3, or the absolute value of x plus 3. So we want to manipulate this to somehow find this in. So if we take this, we can factor out the absolute value of x. And that's going to leave us with x plus 3 plus an epsilon. And great, we found our absolute value of x plus 3. So what we're going to do here is we're going to assume that our delta is less than or equal to 1. Because we're looking for a small delta. So, right. So if delta is less than or equal to 1, and we know that x minus a is less than delta, we can say that x minus a is going to be less than 1. Well, right. So in this case, the a was -3, so we want to find the absolute value of x plus 3 less than 1. We want to find bounds for x. So we take it out of absolute value. We can say that -1 is less than x plus 3, which is less than 1. And we just solve for x, subtract 3 sides, and we're going to get -4 is less than x, which is less than -2. But what do we have here? We have the absolute value of x. So we want to find not just x, we want to find the absolute value of x here. So we can say that the absolute value of x is going to be between 2 and 4. So now we want to look back here and we want to choose the value for x that's going to make this piece here the biggest. And if we look at the endpoints, we can choose between 2 and 4. 4 is clearly bigger than 2, so we're going to choose for it to be 4. We can say 4 times absolute value of x plus 3 is less than epsilon. in solving just for x plus the absolute value of x plus 3, we're going to get the absolute value of x plus 3 is less than epsilon over 4. So now that we have this isolated, we're going to choose this to be our delta. But we have to be careful because we made the assumption earlier that our delta was going to be less than or equal to 1. So when we declare what our delta is going to be, we're going to have to choose the minimum of 1 and epsilon over 4. Great. So now we want to prove that that actually is true. We want to prove that when we choose, whenever we choose x minus a to be less than our delta, that this is going to hold up. So let me erase some stuff. I want to keep that. Just the rest of that stuff. Right. So we're going to start with the x minus a, so that's going to be the x plus 3, is less than delta. So less than delta. What our delta we decided was the min here, so we can say 4. We can multiply both sides by 4. Get 4 x plus 3 is less than epsilon. And now, over here, we decided that absolute value of x is always going to be less than 4. So we can say that this is going to be less than this. So then x plus 3 is going to be less than our epsilon. And if we distribute this in, we're going to find the absolute value of x squared plus 3x is less than epsilon. And I could say, if I subtract 0 from this, it doesn't change anything. So I could say that x squared plus 3x minus 0 is less than epsilon. And that's what we wanted to show here. So that whenever we choose a delta, it's a minimum of 1 or epsilon over 4, we're going to find that this is true.